Okay, so you are already familiar with Redis database, which is good. And then here so today's lesson is what is AWS service, what features it provides, how powerful the Redis database service is. So that's what we will be covering. And when I was studying this Redis database, like I was amazed because it's like super powerful database. Okay? And you will learn about some new concepts such as read replica and send instance that I will talk about soon. Okay, Redis database service. AWS supports the most popular file and Redis database engines, such as MySQL, Oracle, MS SQL. So it supports them. And also, they have built their own database in the cloud, so which is Aurora. And Aurora engine supports MySQL and Postgres database. So basically, if you're running a new application, like if you want to run your MySQL or Postgres application in the cloud, then just use Aurora. That's what people use. But if there are like some specific reasons that you want to run your database engine as is, then this is what RDS is. But then Aurora is recommended. It provides more features. It's much faster than this regular engines because it takes advantage of these cloud technologies such as shared database storage. So that explains why it's much faster than others. Okay, we will talk about database instance and engine, those 5 engines. In Aurora, so you would have a cluster. Inside cluster, you would have multiple database instances. And then Redis database, it's a managed service. It's a managed service that helps you with some database work. So for example, database backup. So if you manage a database yourself, then database backup, failover, or some other database related concepts on your own. But with AWS, it does some of the work for you. The thing is, so since it manages some parts for you, they have control over some configurations, and you have control over some configurations. So I would say it's like 50-50%. And then how you configure your database is through parameter groups. Okay. And then I will talk about the standby instance, which is a concept applicable to this RDS. And then also I'll talk about read replica, so which improves scalability by adding instances. Okay, let me draw some. So this service gets tricky. Like when I was preparing for the exam, it was tricky. The reason is, so now you have to study 2 things: RDS, and then Aurora. Yeah, I would say this Aurora is used 90% of the time, but RDS is still there, and this is still there, and you will see some concepts in the exam. Like if you are taking associate level exam, they will ask you this. And because of this reason, like it gets tricky, like some same concept. So here we have this standby instance. If you want standby instance, so for example, if this database goes down, then it will switch this to standby instance instantly. Your database will be back online in 2 minutes. Okay, that's what standby is. And then you also have read replicas. Read replica. I can call it read replica. So this is the only and proper way to scale your Redis database. The disadvantage of Redis databases, when it comes to scaling, it's really hard. And what big companies do is they might be doing something called sharding, but that's too complex. So the scaling is, so you can, instead what other companies do is they scale, and the scale out is recommended or scale up. We discussed this in the EC2 and the scaling. So we scale out, and how we scale out the database is creating these read replicas. And I would like to also add some more point in here and now. So basically, if you have a client application, then it can write to your database instance in here. So this is like something called F1. And if F2, let's say F2, it doesn't need to write your database instance. Instead, it only reads from your database. In that case, it can connect to this read replica. So now notice here, like you are uploading some transactions from your primary database. Instead, it's pointing to read replica. And the bottom line now I'm saying this is, bottom line is, when you design an application, like you should design applications, like some applications, it writes and reads, and some applications it only reads. If you manage that way, then it would make sense. It would make sense. If all applications writes, then it's writing, then I don't think you can take advantage of this read replica. In the first place, when you design your microservices, design it in a way that some of them write, some of them only reads. So that's the idea here. And now the confusing thing is, in Aurora, there is no such thing called the standby. There is only one thing called read replica. Okay. And then when this Aurora main instance goes down, then you need something similar to a standby. So what it does is it can promote this read replica to primary instance. So basically the standby is not applicable. So something like that. It is like, looks like read replica. It looks like one concept, but depending on if it's Aurora or RDS, it's different. So you need to, and then I have created some tables in this slide so to make it more clear, but this one is just to give you some idea. And so standby instance and read replica. But again, standby is, it's applicable only in terms of RDS, and read replica is that we have read replica in both RDS and Aurora. And we will talk about the Aurora database, its cluster and the storage, and then its features. And then I will talk about some, I elaborated on this cloning because the Aurora, how it's powerful is, it uses cloud storage, shared cloud storage. And when I talk about cloning, it will elaborate on this, the advantage of this storage. So this shared storage makes this Aurora powerful. So basically, just to give you some, I'll talk about this again. So you have data, and you want to replicate that in multiple database instances in different data centers. With RDS, what happens is that when you replicate data with RDS, it copy and paste. Copy and paste takes time. Whereas in Aurora, it uses the shared database. It just changes the pointer. So it doesn't do any copy and paste. If you want to like replicate your data or clone your database, it just changes those pointers. Under that, it's pointing to the same data. And then they like separated this compute and the storage into groups. Okay, so this Redis database, they do some work for you, and you can still manage your database, configure it, and then since it's a managed service, some access is restricted. Because it makes sense. For example, Redis database, it takes backup every day automatically. If you have full control over the database, you might change something, and that would mess up this future, right? You blocked something or you changed something, and then because of that reason, AWS future is not functioning. Well, okay. To prevent that, they do that. Yeah, RDS benefits. So this is what this service provides. You can run it in your EC2 machine, like you can configure EC2 machine as database, but there are these big features. That's why people use this relational database, and then they create the machine. So first thing is backup, and that automatically takes backup every day. And then so they can also read transaction logs, so which allows you to restore your data to any point in time. So basically select your time frame, and then you can restore your data. And it also gives availability and durability. When you create an instance, you select the ASIS, like you create load balancers, you select ASIS, and then now your data, when you store data, that's stored in 2 different data centers. Notice, like if you run this in EC2 instance, then you have to run one instance in USS 1A, other instance in 1B. So now it's highly available since it's running 2 ASIS. But with this managed service, that's automatic. And now, just in case if database instance goes down, then it can do automatic failover for you. Okay, because there are 2 instances, like standby instance or there is RAID replica, and then it will do it for you. And then let's say that you have database db.yourapp.com, so which is your URL of the database, and URL stays the same. Like they switch these 2 instances under the hood. Okay, and if you do this yourself, then it's like something you have to do. Right? And it can increase your read capacity. It will help you to scale out your database by creating RAID replicas. So you can upload significant amounts of RAID operations from the primary database. And also it provides to the security, all the data that's going to this database and that they stored in the database, they all are encrypted. And then it also allows you to manage your database, and you can see you would also have those metrics. So for security group and so on. And when having database on EC2 instance, you will lose all these benefits, and doing this task for your databases is on you. So that's why RDS is recommended. So database RDS, you create that in VPC. Since it's in VPC, then you can manage who can access the database using security groups. So this is new thing. I learned that. So you can also use IAM tokens, like those permanent session tokens, those tokens to log into your database. You can do that. So if you do this, then that's extra point that I can add to your exams. Okay? Try this. So there is a way that you can use IAM. And RDS supports 5 engines: MySQL, MariaDB, Postgre, Oracle, and SQL Server. And then RDS can get even trickier. So for example, we have talked about this. There are 2 types, right? 1 and 2. And then depending on these engines, like these features are different. So for example, now we have 2 bigger variations. In variation 1, then we have 1, 1, 1, 2, and there are 5 different variations. Right? Depending on that, like which engine, it gets tricky. But in this lesson, I will not go deep dive into these 5 variations. You just need to know this big picture, 2 different engines. Okay. Aurora. So basically RDS supports these 5 engines. Okay, so that's like in general we call it RDS. And AWS created their own database by taking advantage of cloud technologies, and their database supports MySQL and PostgreSQL. If you have MySQL database, then just spin up Aurora database. Select your engine as Aurora. That's it. You have MySQL and PostgreSQL, just select Aurora. Okay. So for non-Aurora engines, you can select storage volume type. In Aurora, like it's managed by AWS. Okay. But in terms of this non-Aurora, you would have option to select a database. Similar to EC2 instance, it's the exact same, but the general is just general cost effective. You can use it for dev environment, and provision is for production environment, and magnetic is much slower and cheaper. I want to interpret on day 2 we had too many concepts, so I couldn't talk about this IOPS credits in general purpose volume. So that's something I will discuss now. When I was preparing for the exam, I received this question, something like this. You have a production server, EC2 instance, or RDS. It doesn't matter. They use the same EPS, product storage. And its type is general purpose EBS. So it's not magnetic, it's not provision, it's this general purpose. Okay. And the problem is what they're getting in the production is the application intermittently gets so slow. It gets so slow. You send the push and it takes so long to receive a response. And then you might be checking, like you check your CPU and memory utilization of that resource, but this is pretty low. But you are still getting that slowness. And what would be the cause? Okay, so question was something like this. Makes sense? And then the reason is because of something called IOPS credits. I'll show you that in the console. So basically the answer to this question in short is it's not related to server, CPU, or memory. It's related to your hard drive. Your server is fine, but the bottleneck is on the hard drive of that server, like that EBS volume. That is the one that's the bottleneck. I will show you that in this EC2 console. In EC2 console, we have EBS. That's the exact same storage that RDS use. It's RDS. It's not Aurora, right? Okay. RDS, and if you Aurora, they have a completely different storage managed by AWS. But in RDS, we manage the storage, and it's only applicable when you are talking about RDS, not Aurora. So general purpose. So I made this by default here. They select 100 GB. And notice this IOPS here. IOPS here. So it says the baseline of 3 IOPS per gigabyte, the minimum of 100 IOPS, and burst stable to 3000 IOPS. Okay. So what that means is it's base. So this is what you see is it's base IOPS. So this is the worst case scenario. This general purpose hard drive supports 300 input output per second. It's the worst that you can get. So basically they get that error because it hit that base performance. But then it gets faster. And then there is something called burst stable. So burst stable means it's like number of IOPS at the time, right? So basically this volume, this IOPS credits, they support 3000 IOPS. And then I'll just show you it in the diagram. That would make it much quicker. So here, so this blue data points are your IOPS credit. So by default, in this case, it's, let's say 3000. By default, it can handle 3000 requests per second. Let's say like for 15 minutes or 30 minutes, it can sustain that 3000 requests per second. But then after that burst, it would run out of that credit and it would hit the minimum or the base IOPS. And then if there isn't any new request in here, then it would start accumulating credits and then hits to 3000. And then if you have a burst, then again, you will lose these credits. So something like that. So basically then when you choose general purpose SSD, it's burst stable 3000 means it's like it can sustain this 3000 IOPS for a certain amount of time, 15 minutes or 30 minutes, and then it hits base. Makes sense? If you select provisioned IOPS, then you can just give how many you need. But this product is more expensive. For general purpose, this is calculated based on this size. If you want to increase it, let's make it 200. And it's increased to 600 because it's this gigabyte, 1 gigabyte is equivalent to 3 IOPS. So this volume size multiplied by 3. That's how much base IOPS you can get. Notice here, okay, 2000. I'd make it 5000, so its base now increased. So our hard drive input output is increased. You make it 1000. Notice here, then it would always sustain that maximum number of IOPS. When your volume size is more than 1000 gigabyte, then this base IOPS, it's not applicable because it can always sustain the maximum. Notice if I make this 800, then it's multiplied by 3, so it's 400 is base and it's the maximum. Okay, bottom line is if you get confused, then take your time, go home and read those slides. Bottom line here is when you choose this general purpose volume, the IOPS depends on its performance. IOPS means its performance depends on the volume size. So that's what this slides for. So this is a database parameter group. So this is how you configure your database. And maybe so like you are familiar with MySQL database, but maybe you haven't configured anything with database. So that's fine. I'll give you an example of configuring a database. So for example, when you install, just to give you some idea, when you install MySQL on your laptop, so there will be some default configurations, right? The default configuration are already there. So for example, default configuration might be maximum memory utilization is 40%. So this is the default setting. When you install it, it's 40%. And because on your laptop, there are other applications running. So it cannot use 100 all the memory only for running MySQL. Makes sense? There is a configuration something like this, and you install it and it works just fine. You never notice like there are configurations something like this. But then now let's say that you're defining your database to production. Let's say now, like prod environment. In your prod environment, you have dedicated server for database. Database dedicated. Okay, makes sense. And now you install your MySQL database, and default configuration is 40%. Like you developed that server all for your database, but then this MySQL, your database will use up to 40% of your resource, not 100. Are you following this statement? So because of that reason, like as a database admins, what they do is they change this default configuration from 40% to 100%. Because this is server for dedicated for database. This is just an example of configuring database. You might need to configure something like this. And then if you wanna, now you want to change this 40% to 100%. How you do it with AWS RDS is through parameter groups. Okay. And then there are some configurations that I changed in my last work, which are quite popular. So for example, maximum number of connections. So let's say that you have database, your database, and let's say by default, it allows 5 connections. 5 connections. And now your application is running on EC2, right? EC2. And then you use a scaling group. So there could be n number of EC2 instances. So let's say it's like 10 EC2 instances. So basically you are running your running your application on 10 machines. So first one, it works fine. Second one, it works fine. But the sixth EC2 instance, it will not work, right? Because it only allows 5 connections. So this is something in dev environment, we had a smaller server. This number of connection is calculated by instance size by default in AWS. So since we had smaller instance, then our number of connections was small. But then we had our environment applications running on many machines. And then when our Java application starts, like it fails when it's starting. And then so what happens is that we deploy our dev environment, and I look at the target group of the load balancer and where it marked unhealthy, because there's something where health check is not working. And then at that time, what you do is you go and check your log in CloudWatch. And then I open it up the log to see what's going on. And then it says like maximum number of connections. And then basically I need to go to parameter group and change this configuration. So for example, I will show you this once I launch it. RDS instance. So by default, it's like one formula based on resource database size. But then I changed max connection to 64 directly. Another common configuration is enabling binary log, bin log. So basically what happens is that, so now you have your database in here. And what I was doing at my last job is we wanted to replicate this database account. So this was in one account there, and then I was working on multi-account migration. So I needed to migrate my database to another account. There's a database, and this is account B. And if you want to like export your data in this database, then that's what binlog is. So basically, there is something tool called database migration service. I use that in between, and that reads the binlog. It's the binlog. The binlog is all the queries that you are executing against install, and then it reads the log and then runs those queries against new database. So it's used to export your data to some other data source. In a nutshell, binlog is used to export your data in a database to other data source. And you have to enable this. By default, it's disabled. So if you want to enable, then you can go ahead and check it in here. So that's about it, about this group. Backups. The backups are automatically enabled in RDS daily with the retention period. So let's say I want to keep this backup for 1 day or 2 days or 3 days. So you can configure that yourself. This automated. And not only that, so this one, I'm not sure if all those engines support, but some engines support. I'm sure Aurora supports this. So basically, if you have this daily backup, let's say that you can go back to yesterday. That's the market. But now, if you want to go back to data 10 minutes ago or an hour ago, in that case, you can use this feature. And then not only this, you can take your snapshot. You can take backups manually, which is called snapshots. And when you restore backup, so this backup or snapshot on a new instance, then it takes 45 minutes. You have database and you have backup. And if you want to recover your backup, it takes 45 minutes. But most businesses cannot afford this 45 minutes. So that's the reason why we need standby instance. Access. So recovering this backup snapshot takes 45 minutes. To improve this, you need standby, or that's known as multi-AZ. So in 2 different data sets, you have 2 instances. When you do this multi-AZ option, like when you are creating a database instance, you will see this multi-AZ configuration, and that's like how you are configuring this standby instance in here. In RDS, not Aurora, I'm talking RDS, standby instance is synchronous. You put data and it copy and paste that to the other instance. Whereas in Aurora, this data is replicated to your standby or red replica asynchronous. That's some difference there. And there is a standby instance. You cannot like here standby instance. It's sitting there in case the primary database goes down. Only that purpose. So you double pay for this because you have exact same 2 instances, but then the second standby most likely it would not be used, right? So you're double paying just to improve your time from like RTO time from 45 minutes to 2 minutes, and then you double pay. Like there is a trade-off there. This is a new feature. I think this was just a month ago. They come up with something called cluster, standby cluster. So what it allows you is you can read some data from standby instance. It's there in case of the premises failure. Cluster, you can read it. But this is yeah. And during outage, standby instance or red replica is promoted to primary instance in 2 minutes. In Aurora, it's even faster, so in 2 minutes. And now you improved your RTO time from 45 minutes to 2 minutes using this multi-AZ deployment. Or multi-AZ means it's standby. And then standby again, there is instance and cluster. And like now, bit deep diving into that. And there are two types: instance and cluster. If you have instance, you cannot read. If you have cluster, you can read your standby and synchron.
Professor,
Yes,
they both have the same price.
I think so. Yeah, if you have this standby instance and it will charge double. Yeah.
Okay, then why using the instant? The cluster provides an extra feature, which is the ability of read.
Exactly. That's why this feature is published like months ago. 2 months. I updated this last block. Before that, we hadn't this feature. We just pay extra, pay double for. Yeah. And I would say that this standby instance, these read replicas, they cost same as the primary instance. They are expensive. Because again, think about this. You select your database sites, like you select EC2 sites, like 2 GB RAM and CPU. And then if you have one read replica or standby, then you are creating the same instance twice. And then they charge like every hour. So it's super expensive service. That's the reason why I highlighted something in here. Like don't launch or practice RDS in your personal account. It charges a lot. And now it will go up drastically. So currently your credit, AWS credit, so it's only $12. So I launched all the, I don't stop or terminate my instances, but I highly encourage you to do that. But maximum case you would get $12. And after doing your RDS lab, it will get like 30, 40, 50 and more. Because there are like multiple instances running. Your primary instance and your standby or read replicas. Okay. And standby instance, not only just in case the primary goes down, it can also help you to provide this feature, like data redundancy, because this makes sense. Your data is stored into place, and it also eliminates I/O freeze. If primary database I/O freeze is frozen, then your standby is used, and then it also can minimize latency spikes during system backups. During backup, you would use your primary instance's CPU. That would make your application a bit slower. And during the time period, it can come to the picture. And also it can, if you, when you do maintenance on your database, like upgrading its version. In that case, the standby replica can play a role there. This is how it looks like. It's a region. And your database instance created in this US is 1A. And then your replica is created in different AZ when you do this image. And then you have still you have read replicas in RDS that can enhance your performance, scalability, increase your read throughput and durability. And replication is asynchronous, so reads are eventually consistent and all transactions are secure. So you would get like 10 millisecond latency. It's asynchronous, but it's not that bad. When you send a request, you might get stale data, and when the second request, I guarantee that you will get new data. Latency is very low. And replicas can be promoted there. So from replica, you can create a new database. And the replica can be set up as multi-AZ for disaster recovery. But now you can create maybe another read replica in UASYST 1C. In that case, like they say that 1A and B data centers go down, then you still have your data. And this is in terms of RDS, it's not in terms of RDS, this is how they replicate. So you have main database, and then you have replica standby, and then you have read replica. And they all, when you create an instance, CPU, your storage and computation, they are in one place. Like it's just like one server. And then copy and paste. This synchronous, read replica is asynchronous. And then they all maintain their own storage. Notice this. If I elaborate on, compare this RDS with Aurora. In Aurora, notice they all the databases, they have this shared data storage. Like previously, this one instance manages its own storage. So they are coupled together. And here they are decoupled. Now you have two different components. Here you have only one component called instance. And in your instance, you define how much hard drive you need. Let's say 1 terabyte. If you're storing 1 terabyte, then you have to define that. In Aurora, you don't even define hard drive size. Like they have scaled it for you, and it's shared. What you have is you only have these instances, and these instances are only responsible for computations or handling those queries and connections. And your actual data is stored in something like EFS. It's stored different. So now notice here is like first you have this computation layer, and then your data storage is 2 layers. Makes sense? Okay, I'll talk about this. Okay, let's take 10-minute break. And then what we will do after the break is we will launch a new instance. This is like all theory. Like when you actually launch an instance, you will not notice anything. We will launch our new instance, and then after launching that, we will talk about Aurora features. They're both pointing to the same thing.
But the fixed response is working, no problem. Any URL redirect is working, but the target group, I'm not sure why it's working for us.
Okay, I think I.
I think target group setup is okay because for default it is working. Target group one is working, but when we use the target group one for /FN, it is not. Yes.
It's not the technical concept related to this cloud answer. Basically, what's happening is it's working. Okay, guys. From configuration perspective, there is no issues. The issue here is the only web page you have is like this is slash, right? If you define one more pattern, like after F1, if it returns like some web page, then you will see this.
So I have to put the whole URL and slash F1 like that.
Okay, so basically what's happening is when you do this, it's forwarding that request to your server. Your server request receives this request, and it's trying to return what's inside. Like if you web page that's associated with this app.
Tries to go to that module.
Yes, exactly. Thank you.
Facebook slash
Here, when you do this slash, by default, it returns the index.html. But when you do F1, your server receives it, but behind this F1, there is nothing. Because of there is nothing in here, it returns not found.
So how can we?
Like, well, just Google it how you can add page after this.
In the document, just like.
It's not no, it's not related to AWS. It's not related to AWS. Instead, it's related to your application. In your application, there is root folder in here, but then in your application, there is no. Your application is not handling with this slash X1. Yes, how you can add this path in your application, then it should. Or you can run Lambda, right? Instead of launch associating with EC2 instance, you can create one Lambda application for F1. That would be easy. Because I don't know how to configure this slash F1 in Apache, but if we associate that with different Lambda function, like if you have two different Lambda functions, they are like two different resources. They can handle those. One returns header from F1, the other one returns header from F2.
Yeah, I need to check this.
Okay. The basic thing, you practice this, I would say, yes, it's the from configuration perspective, you are done.
We don't get last time we were talking about like if it goes to default target group, why it cannot go to /1? Because I was in the recording and it was just a similar.
If we do this like and set the path. Yes. Actually,
Let's say
and redirect to a new.
not redirect, just okay, redirect to the erode page or something static response.
It should work, right?
Yes,
Yes.
like if I my URL /erode and I want to return a static response like 404.com, something like that, it gets the response.
So when I give you the proper statement, it seems like I didn't give you the proper reference description. So what I would change what the description is. Right? Here. Instead of instead of pointing to this EC2 instance, I would ask you to point to lambda 1 and lambda 2. Okay.
You can do that.
You can.
Yeah. Send a static page.
Yeah, that works. But lambda makes more sense because these are two different applications. So you have two different lambdas. It's not running on the same thing. Like now, even if there's different responses, and logically that's not correct. Like a one zero return.
For lambda, I think is.
What?
Set the lambda function.
Yeah, something like that.
Redirect.
Yeah, by the way, can you I see? Yeah. It's not here. So how you can do that, I just did it.
Okay, or
This gonna be target group.
already I have it and lambda.
Yeah, you know, like register the target. So basically, when you do F1, it's forwarding to target group. It's not forwarding to EC2 or lambda.
Yes.
And in that target group, you can associate lambda instead of itself.
Okay. Okay, I got that.
Okay, you got it.
Sure.
Yeah, that's true. Before
Okay, sir.
Lambda is equal to theta.
You can't go in. It's better because it's well established. You are time expert person.
Lambda
Okay. Assignment. So it's like, I'm trying to practice an assignment, but you say that there is no grade, right? It's just no me to practice. How is it like? That's what I'm.
Let's meet in the afternoon. Okay, let's continue, everyone. I'm gonna launch an RDS instance with Aurora instance with primary instance and one read replica that we will connect from EC2 and run some queries. Okay, so for that, so since now we have these two different resources, RDS and EC2, we need to this access management, like how this EC2 can access to RDS. So last 2 months ago, they released a new feature, small update that you can connect, like they will do the configuration for you. They will do the configuration for connecting from EC2 to RDS. But in our case, since we took this course, we will do this configuration manually. So please do not do that automatically. First thing we need to do is access management. How EC2 can access to RDS. The first thing is you can connect with IAM, but in this case, IAM is not required because we will be running those RDS EC2 in one VPC. Since it's one network, they can connect using this network. This is the one network, you don't need any IAM. Like you need IAM to connect to other services because those services are public services. They are not in your network. In that case, you have to provide IAM tokens. In our case, since it's in one VPC, one network, you have to do that. You can do that. You don't need IAM, but you still need to write security group. So first thing, we need. I am setting up this first. So let's create a security group for database. Aurora. So this is most security group. So here we will define who can access to our database. So here, let's define who can access to our web servers. What I would do is we will be launching a MySQL database. So MySQL runs on port. Do you remember? Yes. MySQL runs on this. You can just simply MySQL Aurora 3306. Okay, so we will assign this security group to our database. So here we are allowing that port. Great. The only thing now, who can access to it? You shouldn't use this probably, right? I would say like one of the web servers, maybe existing one. This my web server behind load balancer. So I'm gonna use this server. So let me check. I will use existing server. You can create new one. It's up to you. I'm just lazy, so I'm using. Let me just double check here. I have some instances running. So for example, this server, let's see if I can connect to it. I think yes. Okay, cool. So we will be I'll be using this instance. And its security group is my web server behind load balancer. So I think that's this guy. So this is security group. Notice here, this is a security group for this web server. So I'm gonna use this, but this is just for demo purpose. I wanna do it like quickly. In real life, what you do is you create the server that you are using for connecting to your database or like some other private resources in your VPC. Those are known as this Bastion server. Okay. The technical, it's still server, but we call it Bastion or Jump server. Maybe I can break that over here. Bastion or Jump. We have explain. Or what people do is, and I think you are familiar with PHPMyAdmin. So when you install PHPMyAdmin, they give you one web app that you can connect to your. That's exactly what we did at my last job, because it's hard to work with this terminal. Like you have to write all those queries, but instead we configure PHPMyAdmin, run it on ECS, and then that connects to database. So we just connect to this PHPMyAdmin, and that connects to our remote database in RDS. Or anyway, so it should be it. I think that's all. Create the security group. Now, when I launch a database, I will select this existing security group. Am I missing something? What is here database group? We did this. Yes, that should be. Let's move on. RDS. Okay, now we are on RDS. We will use this. I'll close this too. Create database. Create database. Okay. You have these 6 options. So we discussed that it supports 5 engines. So we want Aurora. Most cases we want Aurora. If you select the other 5, it will become RDS. And this is compatible with MySQL, so I am fine with that. But at my last company, our directors were talking about migrating database from MySQL to Postgre. It looks like Postgre has some more features, such as supporting JSON, I think. I just checked one plug. So anyway, so MySQL works fine. And here you select the database version. Major version is MySQL 5.7. So we are fine with that. This is not production for sure. If it's production, I think it would select provisioned IOPS, which would cost more. But in our case, we are fine with general purpose. Database name, cluster name. So we would create a cluster. Inside that there would be multiple instances, like one. In case of Aurora, there would be one primary and many reads. So my first DB cluster. Here is your username and password. You can use that, or again, you can use IAM credentials. That's that. But anyway, we will do the traditional way. So I will change admin to root, because that's I am familiar with. Most people use root, I guess, instead of any name, but I will just follow the standard and make it root. And password is, I put some password in. You would need this to connect from ECT. So I put my password in here. And now this is where you select your database instance size. Notice, like, if you have one primary, 5 read replicas, then this will charge like 6 times. So this is like the size of your instances in your cluster. I would select these cheaper ones are burst stable classes. Select cheaper one. Select this, and then I will see if I can make it even smaller. Maybe click on this. Yeah, phone. Select the smallest one. I think it should do it. It's too small. So the smallest I can find. You can just go ahead and go with this small, which is fine. So one thing to make sure is once you took those screenshots, delete this immediately. Okay, do that. So you might stop your instance. In that case, after a week, it starts automatically. Okay, so you need to make sure you terminate your. Okay, so anyway, like I selected it here, and now this is multi-AZ. Multi-AZ means it's standby or read replicas. Basically, what it's doing is your data is replicated in 2 servers. Those are in 2 different AZs. So it's recommended for scaled availability. Creates an Aurora replica for fast failover and high availability. That's exactly what standby is, right? So if you selected RDS, then you will see slightly different UI. That might be saying something like read replica, standby, and standby instance and cluster. Just check that out, how this UI look like. Okay, so we want to do that. We want to test like how it does that. So we select this, it will create. This is the new feature that if you select this, it will configure it automatically. But for now, we will do it manually. So fine. So you select VPC subnet group. I think you can go with default. The only thing you have to do in this step is you make sure that you selected the previous security group. So there should be security group for database or so select this. The rest just fine. Okay. And like when you do this assignment, like I take time to explore these options. Like I selected this here, I found the part. So I'm fine with that. I did here password authentication. That's what we want. I put root and password there. Alternatively, you can use IAM. You must deselect this. Okay? So this is restricted by AWS Academy. This is okay. This is fine. Enabling. Oh, maybe it's one of them. I think yeah. Just deselect this. We don't need this enhanced monitoring. Deselect this and initial database name. We can create one here. Or you can create with SQL command. So let me see the scripts I prepared. I don't think I have a command to create a database. Show databases, create database. Okay, anyway. And I'm just creating this. You can create your database manually once you. So when it launched, it would have this database. And here, if you scroll down, you will see backup in here every day. It would retain it. There would be backup automatically every day. Here you define how long you want to keep it. 1 day is fine. And enabled encryption is enabled by default, so it uses skippers and maintenance window means you are creating a database version. Fine with that. That's pretty much all. And I highlighted the steps in here. Just follow these steps. Do not follow those screenshots. Just refer it. Like if you get really stuck, if it doesn't help. Otherwise, I highlighted them. Enable enhancement, deselect this, like main steps in here. It will save your time. No preference. Yeah, that should be it. Let's see. Okay, looks like it's going. So cluster is there. So we have primary instance in here, and then we have one red replica in here. Okay, it will take some time, like 3 to 5 minutes. Just to give you some idea, when you create database, I just want to show you like what UI what's the difference when you select RDS. Like you will see some differences, not that much, but some small difference. So for example, here, when I select MySQL, it becomes RDS, and you should see something like this. The Mate is now you see this cluster instance and here bit different now. Earlier for in terms of Aurora we had on the read replica. Here you have this cluster. Cluster you can read. It's a new to see here. It's new, and then you can get some updated information in here. And then let's see if it's different. Yes. And now do you see here? It asks you to enter like how much memory you want, IOPS, etc. In terms of Aurora, it's managed by AWS, but here you have to do. That's pretty much all. Okay, let's cover a couple of slides, then we will get back to this. I think it will take at least 5 minutes. The Aurora. So it's built on top of MySQL and Postgre. Those are open source databases. And Aurora can deliver up to 5 times the throughput of MySQL and up to 3 times the throughput of Postgre. And it takes advantage of distributed storage. So there is a bunch of videos that's showing like how performant this Aurora is compared to this standard versions. And it's powerful, it's more performant than high throughput. The reason is compute storage is decoupled. When we create RDS, it's coupled, like you define hard drive there, like how much memory. And then as you have seen, so you have clusters because in most cases people have this read replica. You need this to improve. Like there are 2 reasons now in case in terms of Aurora. So first, you need to improve your read capacity, and the second is in case primary goes down, then it can escape. It can promote that read replica to primary. So that's why you have this clusters. Oh, here are some, and then there is cluster has this shared value, and when you store data, insert into your data, so that's automatically replicated is stored in 3 different data centers by default. And primary, where you can do write operations. A read replica, you can only read, and this is asynchronous, but the replication is done in 10 milliseconds. It's almost synchronous. And some features they provide is you can create global database. So which means you can have database in 3 different continents, US and Europe and Asia. I noticed like some students, they call AZ as Fusion. So they are different concepts. Okay, they're not. AZ is data centers, and region is like it's continent. Encapsulates multiple bases. Okay, this one global database, it means the multiple regions. And this is the disaster. Okay, built-in fault tolerance. You can do. There is something called parallel queries, which means you can run some analytical queries without slowing down your transactions application. But that's the main reason why these companies have data warehouse or data lake. If you do analytics on transaction database, then it will make your application slow. The export this to somewhere else and then do analytics. So then that would not impact your application. You can also integrate Aurora database with machine learning services in the AWS cloud. So that's why AWS is like more enterprise. That means like it has more services, and you use one service, and then you can integrate that service with other services. That provides like powerful features that organizations need, but it's easy to integrate. And then it also has caching layer in it. And Red Replica, so they share this the same underlying storage, lowering costs and avoiding the need to copy data to the replica nodes. And you can have up to 15 replicas. And maintain high by collecting Aurora replicas is pretty easy. And our Aurora phase over, automatically phase over to replica. Case primary goes down in 30 seconds. And so again, doesn't copy and transfer data during the replication. Instead, just share the underlying storage, which helps reach minimal replica lag, which is less than 10 milliseconds. And here, like what happens when primary goes down. So first case, we already know that if there is a red replica, then it will promote that to new primary in 30 seconds. So this is new. Again, I updated 2 months ago. When I prepared this 1 year ago, 1.5 years ago, it was 1 to 2 minutes. But then after 1 year, it's improved. And if there isn't any red replica, then again, it's automatic. It would bring back your database by creating new replicas. Right? They do have your data. So even if there is no red replica, it looks like they can bring back a new database for in 10 minutes. I haven't checked this yet. I think I read this in one blog, maybe. You can also, it's something that you can test this out. It's like something from documentation. So here are some differences. Mafia is a deployment. It's for failed over. If primary goes down, it will AWS will switch database automatically. So in the errors of RDS, you have this set by instance, which is synchronous. And in Aurora, you do have this red replica. In terms of scalability, you can, if you want to scale it at RDS, then you can new red replica. In Aurora, you also have same red replica. And also the main difference is its storage. That this instance, so this is the storage is inside the instance, but in Aurora it's shipped. Yeah, let's refresh this. Okay, save a label. It's a writer instance. So we should be able to connect this. And this is red replica, it's still being provisioned. I want to show you the parameter groups. Now you want to configure this. So that's how you do this in this parameter group. So here currently, since we didn't define any custom parameter group, they are using this defaults. So let's see what's inside the default. So select here. And then let's see like connection timeout, maximum connections to do. This is something we discussed today. And this is here. It's a weird formula, but what this guy is, it's calculating number of connection based on instance size or database. We can edit this to 40 and save. Okay, the idea is here, you can save it. And also the twin log. Oh, this is a default. So default you cannot change. You need to create a new database, new parameter group based on this default, and then you can change it. The bin log, you will see that in here. to enable binlog, I think you changed something. Okay. Again, you will find that configuration. You change that to something. So this is what how the div configuration looks like. If you click on this database, you will see these endpoints in here. You have two endpoints. Let's just do this. Here. Your primary instance URL is here. Your read-only URL is with RO. Now you have all you need. You have the URL to primary and read replica, and you introduce username and password when creating. So username is root. Password, something that I remember now. So let's check. Oh, it's terminated. I need some scripts. I need this. Okay, so first thing is, so we have to install MySQL client, so it will recognize MySQL command. Maybe sudo test, since we are installing a new package, and yum install MySQL, and then it, yes. That's it. Now we got the client, so it would recognize this command now. And this is the MySQL. We just installed this package, and the host name is, let's connect to this primary instance first, and then port is 3306, user is root, and it would ask me to enter password. Following. That's it. Enter. Asking me password. So. Cool. I am on it. Okay, you get an error. Let's get an error. You get this error because of security group. Just make sure that you, as long as the security group allows it, then it should be. We created that database here. Show databases. Okay, this is MySQL databases, and we created this university as the initial database. Now I can do whatever I want. So, for example, go here, create tables, and insert some data. I think I have to do something like use university. Okay, now it's using this database. Now let me try. That's this. Okay, all set. And select all from what tables teacher. And then it shows, and then you can select them. Okay, it functions, but under the hood again, this RDS, it's powerful service. We have since this backup and this failover, this replica, and even more. Okay, I can, if I do the same step and connect to this instead of this prime now, if I do this, and if I try to insert some data, then I should get some error, like it's saying it's read-only mode, something. So that's pretty much all. Yes. Yes, for sure. Right. Yes, for sure.
Showing the list of capabilities in the module.
The Amazon is short.
the previous,
Here. It's your, here you are managing your infrastructure, not your database. This is like how your database infrastructure look like. So you have two things, your application and infrastructure. So this is for managing infrastructure. The database, those databases, you can search into that and see what is that. Yes.
Can we force the backup or through a replications after we make any changes in the database? Or we have to wait for the schedule itself?
You can take a snapshot yourself. Just select and take a snapshot. So here, let's say you add a bunch of records, and then you should be able to add new record. Take a snapshot. So here. Okay, it looks like you can export your data to Amazon S3. S3 is what data lake is. A data lake is, it's a new term for data warehouse. Okay, so there is something called database cloning. So you can do cloning here, create clone. So what it does is it clones your database. This is something we used when migrating this database to another account. So this is, let's say, source database in account A, and we moved to account B. So we just use this cloning feature. And to replicate, like to migrate our database from one account to another, it took like 2 seconds. And then just, like there is no engineering effort, it was done. But in production, you cannot do this. Like I'll explain that now. So here it's replicated. And now it's basically, again, so in Aurora, your storage and database is decoupled, 2 different components. And then it's just simply pointing to this data. If you make change to your source database, then that's not shared because the new data is not replicated here. It's just sharing the underlying data, just sharing the pointer at that time. And if there's a change in the clone, then like they're just pointing to different. So this is the reason why we didn't use it in production. In the production, you have to replicate changes in real time. You need ongoing data replication. But in lower DB environment, we used this and it was so handy. And then we just focused on the replication of our applications. And this can be used for replicate or clone your database. Not only in one account, you can replicate to a different account. And if you want something like real-time replication, then the tool is called DMS, Data Migration Service. So this is something, this is something you can use. Like if you have these 2 databases, you want to migrate this, you can use this. It doesn't, your database doesn't have to be in the AWS cloud. Maybe database is on your on-premise system, right? On your server. Like between 2 different on-premise servers, you can instead use this service. You just need to give access to this service, and then it will do the job. It's powerful service. It's very powerful. We use this, and that's the job. The last concept, yep, it's the last one. You have serverless. You can create serverless relational database with Aurora. So that's known as Aurora Serverless. And this Aurora Serverless focuses on on-demand scaling. And basically just you create database and that's it. You don't have to select your instance. So it could be cheaper if it's infrequently accessed or you don't know like how much transactions you would have. But this is serverless for the database. They created version 2, so which can scale even instantly to meet your traffic demand. And when you have the serverless database, your size of your database and pricing is based on this capacity units, Aurora capacity unit. Like if it's serverless, then you have this concept called capacity units. Okay. So, and then in DynamoDB, NoSQL database, you also have something similar capabilities. So basically what this guy is, what ACU is, it's 2 GB memory and corresponding CPU. So you can have up to 256 ACUs, which means your serverless database can go up to 512 GB memory and corresponding CPU. I did this a year ago, maybe it's improved actually, it's subject to change. And it starts from 0 and L, and then how they calculate the price is like based on how many units you have. If you check out this video, then it's showing like how it's scaling instantly to meet your traffic. So this blue is number of transactions against your serverless or our database. And this yellow line, it's how they are scaling the database. They are scaling it instantly to meet your traffic. And they are then back it's scaling down, scaling up, scaling down. So it might be cost effective based on the use case. And then like V2 updates. So with serverless V2, it supports multi-AZ deployment. So now your data is in different data centers. And you can create ready replica for your serverless database. And then boom, so this is more expensive than V1. It's like much more expensive. Like they doubled the cost, I think. They increased the cost 50 or 40%. But anyway, this is could be cost effective. Like if you don't know like how many transactions. And then instance billing. So it's similar to EC2, like per hour storage, IOPS, provision IOPS. If you have backups, you have to pay for backups separately. That's why you want your retention period 1 day. If it's 14 days, then you have to pay for 14 days. And RDS is expensive because it creates multiple instances at the same time for failover and improving grid scalability. And even if you stop, it starts. So make sure you're deleting lives. Okay, cool. That's all. Any questions?
So is there a way to check like how many active connection are there to the database?
How many?
Active connection are there to the database.
Your connection? Yes. If you scroll to your right, then you will see this. Connect. Looks like there are 3 connections in here. They do have this because AWS makes this call to check if your primary is available. So there's always like 3 selects all the time because I think they are doing health check on this primary database. So I think you can see it in here. Let's see the monitoring tab. So where you might see some. In the monitoring, I think you see that. So let me check. In monitoring here, CPU utilization, DB connections you see here. That's why it's so high. Is it here? Not sure. Okay. Anyway, you should be able to see those metrics in here. And then if there is something wrong with like memory, you want to free up your memory, clean your cache, then you can SSH into that and run some. 1 second. But here, yeah, CPU connection, variable memory, and network received throughput, read latency. So this is what you can get like out of box by default. Any other questions? Okay, good. You can. I think okay. I'll go over the assignments once. Before that, 2 students came to me, and I realized there is some issue with. They do use other than there, but did you do this? Listener road. Did you practice this? Did you get that not found error? You did workaround, yes. Okay, looks like there is some workaround there. Well, so looks like you can create a folder, and then inside that www HTML folder.
In the same folder, I activated the file app one and started put in the project.
Okay, then it's like easier than what I thought. So basically, in the folder that you create index.html, like create a nested folder called app1 and then put some index.html. Or you can create like two lambdas in your target group. You can associate with different lambdas. Lambda is responsible for it's like different application app1. Anyway, here just the bottom line was to practice this listener rule. Even if you get not found, that's also from a configuration perspective, that's correct. Then it's like something on application side. So that's out of this. So in this lesson, we're just focusing on this cloud deployment configuration. But to this assignment, there are two tasks I would like to discuss about. The second task, I will write about question 0 a bit about here. Second task is run an existing Node.js application with MySQL using this Elastic Beanstalk. So the goal of this task is to experiment how you can deploy existing application with a Redis database on AWS, and also see how Elastic Beanstalk is provisioning the resources. That's what performance services. And this is tricky. It's hard. Like migrating these applications to cloud is hard. What people use is there are multiple. I even avoid this. What I do is I try to work in a team that develops an application from scratch. Because development from scratch is like much easier in a cloud native way. But when you deploy existing thing, you will get a lot of technical errors, like some small errors, right? That will take hours, and you will get frustrated. Like that, again, it's expected. And if you have an existing app, there are three ways. And you can just simply lift and shift. That means your app is running on a server, and you would lift your application and shift on an EC2 instance. EC2 instance is a server, like same server. You can do that as is EC2, or you can use this Elastic Beanstalk, upload your code, and then it runs. This is what you would do today. And there is another way, like if your existing application is containerized, then it would be much easier. You would not get some weird small errors. Anyway, so it's here. It will take time. You will get an error. Just expect that. Deployed this hiking log application on AWS. That is written in Express and RDS. Application is still there. Beanstalk. So first thing is run the app in your on your laptop, right? Your laptop. So with trans, I did this part. So with trans, download the application, run it in your backup. You don't have to do anything. When you click just start, it should work. Okay, you need to make sure you have database. So first thing, run it in your backup. And after that, I haven't deployed this application myself because I know. So I have seen other this before, so I didn't do this. The students who did this, what they did is, when you download this folder, there is something called EB extensions, and you can just delete this folder, because in this tutorial, you can follow the tutorial, but in the tutorial, they are using CLI. But here, you can just simply upload yourself manually. So this is like CLI related configuration that leads to an error if you don't do it. And then zip it again and upload this on AWS Elastic Beanstalk. Elastic Beanstalk. And then go to here, then configure more options and create next. To create applications, you have to do this. You have to select this lab raw. Otherwise, you will get the error that I faced on lesson 1. And then, actually, I don't think it's fine. This is required. And then in the environment variable section, you have to enter username and password. Okay, for your application. But again, you don't create your database separately yourself. Like it should create that automatically. Okay, it should. So you have to give this username and password in the environment variable. Specify when environment variable. And then this is the link, and we will launch this second application, only this second. And here, like remove this, select the lab role, give database password, and this. So basically, this is I broke this here. Okay, repeat it. Anyway, doesn't matter. So, and there's in the environment variable you have, like you give this database username and password. There is a section for what database and username, and then you have to give this environment as production. This is required. And then they say like it runs. And there are some extra. If you do this, then first 1 or 2, and I give bonus points in the exam. So log into your database using IAM instead of username password, and set a phpMyAdmin for connecting to your RDS. This is if they do this. There is no students who did this because this I added recently, and there are students who did this part. It's doable, and that is just to give you some. But that's pretty much all. Okay, prepare for meditation. I would have thought this updated description also. Okay.
So the recording labs, no? So tomorrow morning.
Yes. Yeah, we only have one recording tomorrow, and then that's it for this week.
Tomorrow morning.
Morning and afternoon. Afternoon, we will have. 개체된 나라 나라겠죠. 그랬을 때 어떤 정도로 개체된 나라 모르와서 다위 하는데 비자를 하게. 그래서 işte. 되게 더 없어져요. Mataresa. Stop of direkt. 이거 되겠어. 일대부터 스타트 정확한 나라.
Listas preparadas para novas.
Oh.